So this is our first video in our self-paced unit, so this is the very first learning objective. But before we start learning this new concept, let me just say something about the videos. So as you're watching these videos, treat it as if you were in class watching this in person. So you should be taking notes on the guided notes. When you see me write something on your notes. There's going to be problems for you to try on your own. The video is going to pause. Try the problem, and then you'll see the answer afterwards, and you kind of compare and see if you're understanding stuff as you go along. If you notice that you're consistently getting your problems wrong, you can call me over and I can help you. And then before you go into the practice problems, you can kind of figure out what's going on in the videos. But the benefit of the videos, you can pause to write stuff down if we're going too quickly, or you can go back and listen to a problem or an explanation again. To use those things to your advantage as you're watching through the videos, because for the rest of the semester, these videos are going to replace the in-person, me being at the board doing an example with a class. All that's going to be in video format. So make sure you still take advantage of the fact that problems are being worked out. You can follow along and do them with me, and then actually try problems on your own to kind of see if you're understanding the concepts as we go through. So this first learning objective is about using a calculator to determine an angle in a right triangle. So we're going to kind of see what that means. But before that, we need to do a small review of an inverse function. So we talked about this after we talked about exponentials and before logarithms, because exponentials and logs are inverses of each other. But what you have to remember is that if I have my original function, which we're going to call f, the inverse function is just the reverse. It just does it in the opposite order. So if f takes in 2 and gives me out 5, my inverse function does the opposite. It takes in 5 and gives out 2. So our inverse functions just do the opposite of what we originally have. So what we're going to be talking about in this learning objective is inverse trig function. So we have our original trig function like sine. We put in some angle theta, and sine gives us some y value on the unit circle, or if we're talking about SOHCAHTOA, gives us the opposite side over the hypotenuse. So that's what sine does, the original sine function does. So if we have sine inverse, we're going to write sine and put the little -1 there to represent the inverse function. Well, it's just going to do the reverse of what we have. So this y that the original was equal to is going to go in the parentheses. Or if we were thinking about it the other way, our opposite over hypotenuse would go in the parentheses. And the thing that was in the parentheses comes out over here. So that's equal to theta. So in other words, what is this saying? Our original sine function, we put in an angle and get out this ratio or this y value. So our inverse sine function, I would do the opposite. We put in the ratio, we put in the y value, and it gives us out the angle. So if we're ever looking for an angle as our answer, we're going to use these inverse trig functions. One thing you might see, so if you're looking at your kind of handheld TI-84 calculator, you'll see a button for this. Other ways you might see this is it might be written out as arc sine. So arc sine and sine inverse are the same thing. So these two notations are kind of interchangeable. Your TI calculator uses the little -1 sign. If you're using something like Desmos, you can type in arc sine, and it can do it that way. So they mean the same thing. You might see both pop up. We need to do a... so let's do an example together now. So we know that sine of theta equals 0.35. What is the value of the angle theta? This is just going to be a straight application of our inverse. If sine of theta equals 0.35, we can switch these two things. And in order to do that, we just change from the original function to the inverse function. And now when we do that switch, now theta, the thing that we're trying to find, is by itself on one side of the equal sign. And then this is what I can type in. So I'm going to type it in on Desmos, which you can't see, but I'm going to type in arc sine because that's how it's easier to type, of 0.35 And for this one, let's just say we're going to do it in degrees. So I have my Desmos in degrees, and I'm going to get my theta is 20 point, that's around the 2 decimal places, 49 degrees. All right, so if I know what sine is equal to, then I can figure out the actual angle that happened. All right, so this is just a straight application of our inverse property. All right, so now that you've seen me do an example, go ahead and try this on your own. You know that cosine of theta equals 0.7. All right, try it. I'm going to kind of pause the recording, all right, and then write down the answer after you attempt it. All right, and the answer you should have gotten, all right, again, you can pause it and look at the work I've done, all right, but the answer you should have gotten is that theta is 45.57 degrees. All right, so now we're going to do another example, but it's in a slightly different way. All right, so now we have a picture of a triangle, and we want to find the value of the angle in the triangle. All right, but whenever we're looking at a right triangle, again, we know it's a right triangle. Whenever you're looking at a right triangle, you always have SOHCAHTOA to rely on. All right, so SOHCAHTOA, based on this angle theta, I have opposite and adjacent, which means I have to use tangent. All right, so I can say the tangent of this angle theta, again, I don't know what it is yet, but I know the tangent of any angle is the opposite side, 9, divided by the adjacent side, 6. And now this line is just like the examples we were doing previously. If tangent of theta equals 9 over 6, I can switch from tangent to tangent inverse, and those two things are going to change places. All right, so whenever I want to change where these two things are, I just have to switch the inverse function. And again, this I can type in, and if I'm using Desmos, I'm going to type in arctan, because it's easier to type than tan inverse, but 9 over 6. And Desmos tells me that's about 56.31 degrees. All right, so really similar to what we did. The only thing we had to do extra over the last example is use SOHCAHTOA to make our first equation. And that's what we did here. And then it's just like the last examples. We switch the theta and that value. And to do that, we have to switch to the inverse function. All right, but our final answer is the angle that we're looking for right there. All right, so now it's time for you to try one on your own. All right, make your equation and figure out what the actual value of theta is. All right, and here's the work for the answer you should have gotten. All right, in this case, you have to use sine because you have opposite and hypotenuse. All right, that ends up giving you the angle theta is 12.37 degrees. All right, so those are our examples for this learning objective. All right, how can you find the angle of theta in these right triangles? And the very last thing we're going to have in these videos is a multiple choice question. So I'm going to have these done so I can kind of quickly see who understands what's going on in the video. And if you get the multiple choice question wrong, there's nothing bad that's going to happen. It just lets me know, oh, maybe you didn't completely understand what was in the videos. So go ahead and try this question on your own again. What is the value of theta in this image? And then select the multiple choice answer that corresponds to the answer that you get. And then once you are done with the video, that's when you will get the practice problems and practice everything from this learning objective. So after you answer this question, go get the practice problem to get started practicing this and making sure that you kind of understand what's going on for this learning objective.